This is Pascal's triangle. You'll need it to know it for the binomial theorem, but you'll want to be able to make it yourself. Here's how you make it yourself. You start off with 1, and that's row 0, like something to the 0 power. And then you write a 1 and a 1 here. And then you extend the 1 out, but you add these two together to make 2, and you put 1 on the end. You extend the 1s out, and you add these two together to get 3. 2 plus 1 is 3. You keep extending the 1s out. You add the 1 and the 3 to get 4. 3 plus 3 is 6. 3 plus 1 is 4. And you can keep going forever, but I won't make you go past 12 or 14 in class. Now, what you should be paying to here is the relationship between these numbers and Pascal's triangle. Because if we take 1 and then we go 1, 1, that 1 represents the coefficient in front of the binomial expansion. If we then go 1, 2, 1, the 1, 2, 1 represents these coefficients. So if you had Mrs. Stoner last year, she really emphasized these problems, and if you had Mrs. Cessna, you just did them for one day. So you can decide for yourself, do I pause the video and write down this because I need to really think about it and then pause? Or if you've got it from last year, no big deal, just skip forward to the next slide. This is what the binomial expansion formula looks like in the book, and this is kind of what the example looks like in the book. So like if I had a plus, let's say, 2b to the 5th power, it would be to take a to the 5th plus 5 choose 1 times a to the 4th times b plus 5 choose 2 times a cubed b squared. I'm not going to write out the whole thing, but notice right here that 5 choose 1 is the number that's in the binomial expansion. So this is going to be 1a to the 5th, and it's going to be 5 a to the 4th, but in this problem the b term is actually 2b, and so it'd be 5 a to the 4th times 2b, and so it's actually going to be 10 for that coefficient, but we'll get to that in a second. And then it's plus 5 choose 2. 5 choose 2 is 10, so it's going to be 10 times a cubed, but then b, remember, is really 2b. So it's 2b squared. And so I've sort of run off the screen. But if you were expanding this binomial with the binomial theorem, it would start off with a to the 5th plus 10 a to the 4th b plus 40 a cubed b squared dot dot dot. So I wanted to show you what the formula looked like because it's useful for our next slide. And that's the relationship between Pascal's triangle, which is right here, and the binomial expansions, which is right here, and that calculator NCR button. Because if you look right here, this coefficient is 5 choose 0, and this coefficient is 5 choose 1, and this coefficient is 5 choose 2, and this coefficient is 5 choose 3, and those are now looking at all of the different ways I could expand something that had 5 possibilities. This is 5 choose 4, this is 5 choose 5, and if I did those numbers using the NCR button, I would end up with 1, 5, 10, 10, 5, 1. It's important that you understand the relationship between Pascal's triangle and the part of the formula that looks like this, because if you know that this 5 choose 2 is the fifth row, or like the power of 5 row in Pascal's triangle, you should see the relationship between the row's power and the numbers in the binomial theorem. This is what an example in your book looks like of how to expand a binomial to the 5th power, and this has a lot of stuff in it, and so I want to break it down into easier steps. So I'm going to make this kind of small, giant formula in the book, and I want to show you how I process through a problem like this when I'm thinking about it. So the first thing I'm going to do is look at the fact that this is to the 5th power, and I'm going to write out the 5th row of Pascal's triangle, or the 5th power row. This is a 0 power row, 1st power row, 2nd power row, 3rd. So I have 1, 3, 3, 1, 1, 4, 6, 4, 1, and 1, 5, 10, 10, 5, 1. And so this is the row I'm looking for. And we have 1, 5, 10, 10, 5, 1. My second step is to fill out the powers. So this will be my a to the 5th power, and this is going to be my b to the 5th power. And the a's are going to go down, a to the 4th, a cubed, a squared, a, and my b's are going to go the other way, b to the 4th, b cubed, b squared, b, and then no b's by the 5th. And then I look at my original question, and where every a is, I've actually got an x squared. So this is going to be x squared to the 5th. So a's are going to be replaced by x squared, and b's are going to be replaced by negative 2y. So a's get replaced with x squareds, and b's get replaced by negative 2y's. A's get replaced by x squared, b's get replaced by negative 2y, and I do that in the whole entire problem. So then when I look at each component, the first is x squared to the 5th, and so that would be x to the 10th. In the next component, I have the 5 times the x squared, which is to the 4th power, but it's also times this negative 2 here and the y, so I'm going to put 5 times negative 2, negative 10. X to the squared is to the 4th, so x to the 8th. And b is replaced by negative 2y. I already took care of the negative 2, but you need to have a y right there. So negative 10 x to the 8th y. So in the next one, I've got the 10. The negative 2y right here is squared, because b is squared. Negative 2 squared is 4. 4 times 10 is 40. It's going to be plus 40. The x squared is cubed, so it's x to the 6th. And I already took care of the 2 as part of the 40. And the y is squared, so y squared. And then when I look at the next term, my negative 2y is cubed, because the negative 2 is going where the b is. And negative 2 cubed is negative 8, and it's times this 10 right here, so that's going to be negative 80. My x squared is squared, so it's x to the 4th, and my y is cubed, so it's y cubed. I've officially run out of room, but if you want some practice, you can keep going, or in the next slide we'll look at an easier example. Oh, what the heck, I figured I would do just one more. So this is a cubed problem. So there's our 0 row, here's our 1 row, here's our 2 row, here's our 3 row. Okay, so I'm going to write this as 1 m cubed plus 3m squared w plus 3mw squared plus 1w cubed. And then I'm going to go, oh yeah, but it's not really a w, it's a 3w. So wherever there's a w, I'm going to replace it with a 3w. This 3w is going to be squared. This 3w is going to be cubed. And now to complete the binomial expansion, it's m cubed plus 3 times 3, so back that up, or erase it. 9 m squared w plus, and now on this problem we've got 3 times 3 squared, so 3 times 9 is 27 m w squared, and here we have 27w cubed. So if you think back to that one formula that looked really complicated, it's much easier to think about it with Pascal's triangle. Your homework assignment is going to include some of these problems, but we're also going to do some probability problems because the binomial expansions are pretty easy. It's the probability people get hung up on.